Hi everyone, this is Jayashree, Assistant Professor, Department of EEE. So today we start with second unit, that is electrical machines. Okay, the first topic is DC-DC generator. So before going to the topic, construction of DC generator. First, what is generation? Where we get from electricity? That thing we have to know, right? So energy can either be produced nor destroyed. So we can convert one form of energy into another form. So this is the main thing you have to know. We cannot produce electricity. The energy is converted from one form to another form. So look into this picture. In the left side, there are four pictures. One is this heat. When the coal is burnt, it produces heat. This heat can be converted into electricity, that is thermal power plant. This heat is used to boil the water, which produces steam. That steam is used to run the turbine. That mechanical power, that is rotation of a turbine, is converted into electricity using a generator. This is one form of energy conversion. That is, the current is produced from heat energy. That is the main principle of a thermal power plant. Any thermal power plant works on this principle. A thermal power plant and a nuclear power plant, which uses that is a turbine, steam turbine to produce electricity. Then look into the second picture. This is wind, high wind. This kinetic energy of wind is used to produce electricity. That is windmill. This wind turbine produce electricity from the kinetic energy of a wind. Right. So look into the third picture. So this is a dam. That is water stored in high head on high height consumes a high potential energy. That potential energy of water is used to produce electricity. The water is used to run from the high head. That water is made to run the turbine blades. That rotation of the turbine, that is mechanical rotation of a turbine, is connected with a shaft of a generator. That mechanical energy, that is mechanical movement of a turbine, is converted into electricity in hydro plants. So there are different types of hydro plants. One is pumped storage. That is an artificial way of storing water on the high head and producing electricity. That is used for peak peak hour hydro plants. What you're seeing in this picture is a dam. These are all the natural sources of water. Water stored in a dam. Then it is made to flow from height. Then a turbine is placed in the bottom of in a low level. Then the force, it is kinetic energy of water, makes the turbine to rotate. So this is a hydro power plant, right? So here also the potential energy of water is converted into electricity. This is third type. There are different types of energy conversions. So look into the third picture. This is a tide. This waves in an ocean. We call it as a tide. This movement of a wave, this movement of a tide is used to rotate again the turbine. It makes the wheels to rotate. Those wheels are connected with an alternator generator. That mechanical energy is used to produce electricity. This is tidal power plants. Like this, these are all the conventional sources of electricity. That is, nowadays, renewable sources of electricity is very much common. New, that is non-conventional sources, latest, that is solar. The heat of the solar energy is used to produce electricity. Then gas, natural gas plants are there. So these are all the conventional, non-conventional sources of electricity, which is available all the time. So that's the thing we call it as renewable energy sources. Always the supply, the source is available always. Wind is available always. Heat, that is solar power, is available always. But if you take a thermal power plant, the availability of coal is depleting. It is reducing. So nowadays we are looking on conventional energy sources, right? So identify the various forms of natural energy sources. So here wind is natural source, water is natural source, tide is natural source. All right. So look into this picture. Then coming to classifications of electrical machines. So in this topic, we are discussing on DC generator mainly. Before that, I will look on the classification, how it is classified. Machines are classified basically based on whether it is a static machine or dynamic machine, whether it is rotating or a standby machine. It's classified into static machines and dynamic machines. Static machines is mainly transformer. Transformer is a static machine which is used to transfer electricity from one side to another side. That is from substation to consumers, then to boost energy, then to reduce energy level, voltage level, to increase voltage level, to decrease voltage level. Transformers are used. These are all static machines. Whereas generators and motors are dynamic machines because the rotor is rotating. So there are various rotating elements are there. So these machines we call it as the dynamic machines. Generators, motors are dynamic machines. Then coming to another classification. So static machine is a transformer, rotating machines are DC machines, and AC machines based on the supply. It is classified into DC and AC. In DC machines, it is a DC generator is there, DC motor is there. Then AC machine again synchronous machines and asynchronous machines. Synchronous machines are constant speed machines. We call it as synchronous machines. That is when the speed is increasing and decreasing. That is very fluctuation. When the speed is varying, those machines we call it as asynchronous machines. In synchronous machines, again, there are two types, generator and motor. In asynchronous machines, induction machines are asynchronous machines. It works on less than synchronous speed. Right. Right. Then induction machines are again single phase and three phase. Generator single phase and three phase. Synchronous motor again single phase and three phase. We look on this one by one in the next class. Thanks for watching. Thank you.